everyone. Myself Dr.P.Vijayakumar, Associate Professor, Department of Electronics and Communication Engineering, Aditya University. Today we are going to see variance of a random variable. This is also a fundamental operation of a random variable. In the earlier session we have seen the expectation of a random variable. Now in this session we are going to focus on variance of a random variable. At the end of this particular session, two learning outcomes we will be learning. First learning outcome is understanding the statistical parameter variance. What is variance? Mathematical definition and the significance of variance, and also we will see the properties of variance. In the learning outcome 2, we will apply the concept of variance for solving the real-time example problems. So coming to the definition of variance, the variance of a random variable is a measure of how much the values of the variable deviate from the mean or expected value. It gives you the information regarding the spread or dispersion of the data, how much amount of data is being diverted from the central value, the deviation or spread or dispersion from the central value. So for example, a white light is passed through a prism. What happens means it splits into 7 colors with joy. So the central color is the green, and how much yellow is deviated from green color, how much orange is deviated from green color, how much red is deviated from the green color. So the more deviation you can see from the red color from the central color. The central color is green color. So more deviation is red and moderate deviation is orange color and very less deviation is yellow. The same thing happens with the upper curve also. Violet is deviated more, indigo is deviated moderately, blue is deviated very less. So it gives you the amount of spread or amount of deviation from the central value. So mathematically, variance is can be mathematically defined for a continuous random variable as variance of x is equal to x minus x bar whole square into fx of x dx, where x bar is the mean value, x is the instantaneous value. Generally, the variance is denoted as sigma x square or variance of x. So for a discrete random variable, the variance of x can be computed as summation I, this one summation I p of xi minus mu whole square. So for a discrete version, this is the formula. For a continuous version, this is the formula we need to apply mathematically computation. When we simulate the variance plot in the MATLAB software, this is a simulator graph which is obtained in the MATLAB software. So we have taken two different graphs to show that the measure of the deviation from the central value. For example, assume this is the central value. You can see this is data 1 and this represent data 2. You can see more deviation is happening in data 2. So data 2 is having more spread or more variance compared with the data 1. So the variance of 2 will be greater than variance of 1. So variance of a random variable gives you idea about the how much spread is happening in the given density function. So variance properties of variance which will be helpful in solving the problems. Variance of k is equal to 0, variance of constant is equal to 0. We know that the variance of constant means e of x minus x bar whole square. This is the mathematical formula for variance. Now in place of x, we are placing k minus k bar whole square. The mean of constant is constant, so e of k minus k whole square. So the expectation of 0 is 0. So the variance of constant is 0. Similarly, the second property, also very useful property, you will be helpful in solving the problems. Variance of cx. So e of kx minus kx whole bar whole square. So we know that expectation of kx is k into expectation of x. Applying that, we will get k square into expectation of x minus x bar whole square, which is nothing but again variance. So this is one more property which will be helpful in solving the problem. Combining 2 properties, the third property is if a and b are any two constant, then variance of ax plus b is equal to a square into variance of x. We know that the variance of b is 0, that's why it is not shown here. Next one, variance also can be mathematically computed using a different formula. Variance of x is equal to expectation of x square minus expectation of x whole square. So this is one formula which will be helpful in solving the problems. This formula is derived from the relation expectation of x minus x bar whole square. Expanding this, what we will get is x square minus 2x into x bar plus x bar square. Okay. So this will be 2x square. So e of x square minus x bar whole square. So this formula we use for solving the problems. So in the later part of this session, we will see that how to apply this formula. Next one, variance of independent random variables. If two random variables are said to be independent, x1 and x2, variance of x1 plus x2 is equal to variance of x1 plus variance of x2. Similarly, variance of x1 minus x2 is equal to variance of x1 plus variance of x2. This is based on this formula. Variance of minus x is equal to minus 1 whole square into variance of x. So, applying this, we will get this one. Next, how to compute the variance for a given probability density function. So, we are calculating the variance, how to calculate the variance for a continuous random variable. So, a density function is given to us. Firstly, what we need to do is we need to mathematically derive the relationship for the curve. So, the values are 0, 0, this is 2, 1 by 2, this will be 4, 0. Applying the line equation formula, y minus y1 is equal to m into x2, x minus x1. Applying the line equation formula, y minus y1 is equal to m into x minus x1, we get this relation. So, fx of x is equal to 1 by 4x over the limit 0 less than x less than 2, and over the limits 2 to 4, this is the mathematical equation. Let us compute the mean first, because we know that the variance of x is equal to expectation of x square minus expectation of x whole square. So, first what we need to do is we need to compute the mean value. The mean value is integral minus infinity to infinity x into fx of x dx. 0 to 2 the function is x by 4, 2 to 4 the function is 1 minus x by 4. So, solving this, what we will get the mathematically 2. Next, e of x square. If you calculate e of x square in a similar manner, we will get 104 by 3. So, now variance of x is equal to e of x square 104 by 3 minus 2 whole square. We will get 92 by 3. So, based on this fourth property, we have calculated the variance. Next one is, this is a problem which is related to the discrete random variable. Here also we can use the same formula, expectation of x square minus expectation of x whole square. The same formula we can use here to compute the variance of x. So, we have taken the probability values are given for different values 0, 2, 4, 6. We know that the mean value is for a discrete random variable summation of I xi into p of xi. Solving this, we will get 3. Similarly, mean square value 14. Now, mean square minus mean whole square 14 minus 9, this value is equal to 5. So, one problem which is related to the practical scenario, when a fair dice is thrown, compute the mean and variance of that fair die. So, when a fair dice is thrown, the possible number of outcomes are 1, 2, 3, 4, 5, 6. We know that all the outcomes will have equal probability, all are having equally likely events. So, the probability of getting 1 is 1 by 6, 2 is 1 by 6, 3 is 1 by 6, 4 and up to 6 it is 1 by 6. So, the mean discrete, since the problem comes under the category of discrete random variable, we can apply the formula of discrete formula for computing the mean, e of x summation I xi into p of xi, we will get 3.5. Next, to compute the variance, we will first compute the mean square value. The mean square value is computed as e of x square summation I xi square p of xi. Applying this and calculating, we will get the mean square value as 91 by 6. So, the variance is equal to e of x square minus e of x whole square, 91 by 6 minus 7 by 2 whole square. We will get the variance value as 35 by 12. Next one, compute the mean and variance for a uniform random variable. This is a continuous random variable, uniform random variable. A random variable is said to be uniform random variable if it has the density function something like this. Fx of x is equal to a b 1 by b minus a x. Okay. So, the density function is mathematically defined as 1 by b minus a over the limits a less than x less than b and is equal to 0 otherwise. So, this is the density function of a uniform random variable. So, this density function we will use for computing the mean and variance. Since it is a continuous random variable, the mean can be computed as integral a to b x into fx of x dx. Fx of x is defined from a to b and it is 1 by b minus a. So since it is a constant, bringing outside integration of x, we will get x square by 2. So b square minus a square by 2 into b minus a. So this b square minus a square can be expanded as b plus a into b minus a divided by 2 into b minus a. So it cancels out. What we will get is a plus b by 2. This part will remain. This is nothing but the mean of the uniform random variable. So in order to compute the variance, first we need to compute the mean square value. So the mean square value is nothing but e of x square. So since the function is defined from a to b, x square, fx of x will be 1 by b minus a. I am keeping outside, integration of x square is x cube by 3. So it will be equal to b cube minus a cube by 3 into b minus a. We know the formula of b cube minus a cube, b minus a into b square plus ab plus a square. B minus a cancelled out, b square plus ab plus a square by 3 will be the residue, and this is nothing but mean square value. So variance of x is equal to e of x square minus e of x whole square. So this is the residue, and a plus b whole square by 2 means a square plus 2ab plus b square by 4. Taking the LCM, 4a square, 4ab, 4b square minus 3a square minus 6ab minus 3b square divided by 12. So finally we will get b square minus 2ab plus a square by 12. So this is mathematically equal to b minus a whole square by 12. So the variance of a uniform random variable is b minus a whole square by 12, whereas expectation is a plus b by 2. So there are some commonly used random variables: Gaussian random variable, uniform random variable, exponential random variable, binomial random variable, Poisson random variable. So in a Gaussian random variable, the mean and variance remains same. E of x is E of x only, variance of x is variance of x. For a uniform random variable, the mean is a plus b by 2 and the variance is b minus a whole square by 12. For an exponential random variable, the mean is 1 by lambda and the variance is 1 by lambda square. And these two are discrete version, discrete random variable. So for a binomial random variable, the mean value is np and variance is npq. Q is 1 minus p. And for a Poisson, lambda. So lambda is npq, npq. So mean and variance are same for a Poisson random variable. For example, let us see one problem which is related to the practical scenario. A 40 student beta class contains 25 boys and 15 girls. If teacher asks the question that the probability the boy knows the answer is 1 by 5, the girl knows the answer is 3 by 5. So let x denotes the random variable that denotes the number of students who knows the answer the teacher asked in class. Find the expectation of x and variance of x. So the total number of students in the class are 40. The probability of selecting a boy is 25 by 40. The probability of selecting a girl is 15 by 40. Now what is the question is the probability that randomly a student is being selected in the class and he knows that answer. So based on the total probability theorem, so the selection of boy and he knows that answer, selection of girl and she knows that answer. So this is equal to 7 by 20. That means the probability that randomly selected student knows the answer is 7 by 20. Now we need to apply the binomial random variable concept. Now they are asking us to calculate the average number of students who knows the answer. Average number of students. On an average, 14 students know the answer. Similarly, the deviation from the central value is npq. Applying that npq, 7 by 30, 1 minus p is 1 minus 7 by 20, that is equal to 13 by 20. So after doing the calculation, we will get 9.1. So on an average, 14 students know the answer and the deviation from the central value is 9.1. Next, for a binomial distribution, the mean is 6, standard deviation is 1.414. Find the first two terms of the distribution. We know that for a binomial distribution, NP is equal to mean and variance NPQ is equal to 2. NPQ here and given standard deviation. So variance is equal to standard deviation whole square, that is root 2 whole square, which is equal to 2. variance. So first we need to compute the probabilities. Q is equal to 1 by 3, P is equal to 2 by 3. This is the failure probability, this is the success probability, and NP is the mean value. Based on the mean value, NP is equal to 6, and into 2 by 3, we will get the total number count. So totally 9 is the N value. Now we need to compute the first two terms. First two term means 0, 1. Probability of x is equal to 0 is 9C0, P power 0, Q power 9 minus 0. Applying that, we will get 1 by 3 whole power 9. And similarly, second term P of x is equal to 1, 9C1, 2 by 3 whole power 1, 1 by 3 whole power 9 minus 1. We will get 9.14 into 10 power minus 4. So in this particular session, what we have seen is, we learned what is meant by variance, that mathematical definition, and also we have seen the significance of the variance, and also we have seen the properties of variance. Based on the properties of variance, we applied the same concept for computing the variance for the practical problems. So in the next session, we will be seeing the moments of the random variable. So that also one of the mathematical operation we perform on a random variable. We will see two types of moments. Moments about the origin, moments about the mean. Again, we will see these concepts like mean, variance, how they are interrelated to each other. Okay, thank you.